We use electricity every day. It powers our homes and our gadgets. But did you know that electricity comes in two different types? These types are called alternating current or AC and direct current or DC. AC electricity constantly changes direction. Think of it like a wave going up and down. DC electricity flows in only one direction. This constant flow makes it ideal for many electronic devices. That's where rectifiers come in. Rectifiers are like electrical superheroes that convert AC to DC. They act like one-way valves, only allowing electricity to flow in one direction. This conversion process is crucial because most electronic devices, especially those with sensitive components, rely on the steady flow of DC power. Without rectifiers, our electronics wouldn't work properly. Imagine a world without smartphones, laptops, or even TVs. Rectifiers are essential components in power supplies, ensuring that our devices receive the correct type of electricity to function. Let's dive into the world of half-wave rectifiers. These simple rectifiers use a single diode to block the negative half-cycle of the AC waveform. A diode is like an electrical gate that only allows current to flow in one direction. During the positive half-cycle of the AC input, the diode allows the current to pass through. However, during the negative half-cycle, the diode blocks the current flow. This blocking action results in an output waveform that consists only of the positive half-cycles of the input AC signal. While simple and inexpensive, half-wave rectifiers have a significant drawback. They only utilize half of the input AC waveform, leading to a significant amount of wasted power. This inefficiency results in a lower DC output voltage and more ripple, which can be problematic for sensitive electronic circuits. Despite their limitations, half-wave rectifiers find applications in simple circuits where cost-effectiveness is paramount. They serve as a basic introduction to the concept of rectification, paving the way for understanding more complex rectifier designs. Full-wave rectifiers are like the upgraded version of half-wave rectifiers. They utilize both the positive and negative half-cycles of the AC input waveform, resulting in a more efficient conversion process. There are two main types of full-wave rectifiers: center-tap transformer rectifiers and bridge rectifiers. Center-tap transformer rectifiers use a transformer with a center tap on the secondary winding. This setup, along with two diodes, allows for the rectification of both half-cycles of the AC input. Bridge rectifiers, on the other hand, achieve full-wave rectification using four diodes arranged in a bridge configuration. The output waveform of a full-wave rectifier is smoother than that of a half-wave rectifier. It captures both positive and negative half-cycles, resulting in a more consistent DC output. This smoother output translates to less ripple, making full-wave rectifiers suitable for a wider range of applications, especially those requiring a more stable DC supply. Full-wave rectifiers are the workhorses of power supplies in many electronic devices. Their ability to efficiently convert AC to DC with minimal ripple makes them essential for powering everything from computers and smartphones to sophisticated medical equipment. When comparing the outputs of half-wave and full-wave rectifiers, the difference is clear. Half-wave rectifiers produce a pulsating DC output with significant ripple. This ripple represents the fluctuations in the DC voltage, and it can be detrimental to sensitive electronic circuits. Full-wave rectifiers, on the other hand, provide a much smoother DC output with significantly less ripple. By utilizing both half-cycles of the AC input, they minimize the voltage fluctuations, resulting in a more stable and reliable DC supply. This difference in output quality has significant implications for the performance and lifespan of electronic devices. While half-wave rectifiers might suffice for simple applications, full-wave rectifiers are essential for powering devices that require a clean and stable DC supply. The reduced ripple in full-wave rectifiers minimizes noise and potential damage to sensitive electronic components.